I. So in this video we're going to look at the area of this shape. Okay? The unit area. So if we just ignore this blue line down here for a while, we're trying to find the area, vector area of this red shape. All these lengths are a unit. To do this, we're going to split the shape into two. We're going to call this surface here S1. So the surface bounded by this curve here. And this surface down here, S2. The surface bounded by these two sides and this blue surface here. S1, so we can do that because any flux that goes through both of them is going to be kind of cancelled out, and it's only we're kind of finding a flux here. Any flux that goes through one of them adds. So we can basically define the surfaces however we want, as long as that kind of rule applies. Okay, so to find the vector area, we're simply integrating over the element vector. So let's look at the x component. To look at the x component, we take the dot product of both sides with respect to x. Now clearly, we know we know that we can split this into an integral over S1 and over S2. Like this. Now, we also know that we can write these as two normal vectors. So ds is simply the normal vector of the first surface times by ds, and that's simply the normal vector of the second surface times by ds. Okay, so if we then do that, this becomes the normal vector for this first surface is simply, if we get the orientation right, ex. So we're looking at it from this direction basically. ds and plus ds2 ex. But for the second surface, the normal vector is downwards ey or minus ez. I'll write that down here. Okay, so we then get this. The first one is simply S1 ds, and the second one is 0. Ex and ey are orthonormal. But this is simply the area of this square here, which is equal to 1. So 1 by 1 square. Furthermore, we can do the same with the y component. I'm going to run through this quite quickly now, because we have the basic idea of what we're doing. So exactly analogous to before, we can split it up into two surfaces. Like that. And that is equal to 0, because both these are orthonormal, and that should be z. Actually, that should be minus z, as it should be up here. Okay, and now lastly we have the z component. And I assume that you can see this is going to be 1 without us doing this. Split into two surfaces. I'm just going to run through it really quickly. Actually, no, it's not going to be 1. It's going to be minus 1. That was close. Almost did it wrong. That should be d there as well. So this here is, sorry, we never said that. This here is 1. And then get this first coefficient is 0. We get S2 ds. The area of the area of the second element is simply 1. Then we get minus 1. Therefore, our vector area is given by 1, 0, minus 1. Okay, fair enough. So let's look at this, what it actually means. So, if we go back up here, I need to this up a bit. We don't need any of these anymore. So our vector area was simply 1, 0, minus 1. This means, looking at it from the x direction, we see an area of 1. So looking at it from this direction, we see an area of 1. Looking at it from the y direction, we see an area of minus 1. We see an area of minus 1 simply because of the orientation of this loop. And we can also see that because if we project this red thing down onto this plane, then the loop's going to go something like that. And it's going to have a minus area effect. We also can tell that from the direction 1, 0, minus 1, the area has its greater greatest value, and that direction is that way. If I get this right, that way. So from that direction, the element has its greatest area. The vector has greater area. From looking at it from the y direction, we see that it has 0 area. And there's also another direction we have 0 area, and it's in the direction 1, 0, 1, or constant multiples thereof. That direction is this way. So in that direction, you basically kind of got like a cancellation. Actually no, sorry, even more, it's like this down here. So you actually don't see any area. You kind of see these two things projected onto each other, and you don't really see any area. So I hope that helps helps you like do these questions. They're quite rare. I haven't seen many of them, but